All right. Tell me what you want to see. Yay! Well, day 2 of this was better than day 1 of it, for sure. Mm-hmm. Mm-hmm. I understand. Samantha, did you have any other than the 2 you emailed me?
The first 2
Have you gotten to look at this at all, Ms. McKay?
Yeah.
Good.
I watched the
Okay.
first day. I haven't watched the second day, but you said they were pretty similar. So.
Second day was easy because we used the formulas that are at the bottom of the page, and it's just pretty much plugging numbers into formulas. The second part of yesterday, as far as covering examples, the examples we did from the second half only took 15 minutes or so, and we spent more time working on the first day stuff. Because first day is definitely harder than second day in 8.3. Mm-hmm.
And you have like the n minus n or whatever.
Mm-hmm.
I guess I was just confused that when it's like something negative, it's like signing because you get when you subtract, you get a negative number in there. Did you get that?
If it's cosine, a negative argument is the same as a positive argument. If it's sine, you can just take the negative out to instead of the sine.
Oh, you're talking about the formulas for opposites or something. Whether you go clockwise or counterclockwise, your x stays the same.
Mm-hmm.
So cosine of x is the same as cosine of negative x. But your y's change, so sine of x equals the opposite of sine of negative x. I'm amazed that made sense.
You have your way of explaining.
Well, this, just go,
Yeah, but I can see directions.
Yeah. I don't memorize that. Every time I need it, I just go, the x is staying the same, the y is opposite. I saw that.
Made me happy.
I did see that. And then I saw the 2 guys in Florida who enticed an alligator to bite their arm and then poured beer down its throat.
What? I hate people.
And I just thought, natural selection should just be allowed to work. Why rescue these guys from themselves?
You know what? I'll agree.
Here, gator. Look, it's an arm. There was 2 guys in Florida on the news this morning. Tried to get an alligator, literally enticed the alligator to bite his arm, and then they got a hold of it and poured beer down its throat. This is why y'all are doing while you're doing your Caltou homework.
Someone's enticing an alligator in Florida.
I want to see something like
Maybe after this.
You just have to keep going. But my future life is going to be better because these guys are still going to be trying to get poured beer down gators when they're 60.
They'll probably be dead by that point.
Well, they may be. They may be.
It's probably like anger a bear or something.
It was a good laugh. All right. Emma, did you have anything you needed to see from the homework other than the 2 you emailed me about? Or Sam emailed me about? How about that tangent and secant's the same thing? No, it's not. Did you see the email?
Yeah.
Okay. They did a problem 2 different ways. One of the answers came out 1 plus tangent squared, and one came out 1 plus secant squared. And you're like, well, that's not the same thing. Actually, it differs only by a constant. Because you can put 1 plus tangent squared in place of the secant squared and just have a different constant. Yeah. I'm going to think of Michaela every time I say, it's not a variable, it's a constant we don't know. Okie dokie. Now that Sam's here, we can start. Sam, do you have anything from the homework? Okay.
Never had to face for about it. You were looking at your URL.
Yeah. Like, everybody hold up a piece of paper.
I know.
Yeah, I don't even see the point in doing that. It's like, I'm just giving y'all 100 for taking Cal 2 at the 7 o'clock in the morning.
Yeah, for getting up this road.
All right. So, we are to what Cheryl has been dreading since midsummer, since 4th of July party when her friend told her trigonometric substitution is just the worst thing you've ever seen. It's not the worst thing I've ever seen. I've seen guys pull fingernail alligator throats. That was in the news this morning, Sam. But it takes practice, and you can see that last semester as I was trying to work out a method. We're going to do, this is not today, but tomorrow, we're going to use parts A through I to do trigonometric integrals.
A through S to find like increasing, decreasing.
Yes. Well, I mean, this is better than not having A through I, just given the problem and figure it out. All right, so let's talk about this exploration number 1. Can you evaluate the integral from -1 to 1, square root of 1 minus x squared, using any integration technique you've learned so far? I mean, obviously, the way I worded that, the answer is no. But if you were going to try it, what would you think of trying? Okay. Yeah. No, I don't think that we can do that using any integration technique we've learned so far. What about any geometry formula we know? Because we know that integration, as long as the function's above the x-axis, integration represents area. Is there a way we could find that area without having to use calculus? That answer is yes. Think about it a minute. Think about what the definite integral from -1 to 1 of square root of 1 minus x squared is. Yes. You can do that. Think about y equals square root of 1 minus x squared. Without your calculator, Miss Cheryl. Think about it. Think hard. What does that look like? What? What's that finger doing? Oh, you're saying half a sideways parabola?
Yes.
If that was y equals 1 square root of 1 minus x, it would be, because only one variable is squared. But what, Miss Samantha?
It's just a line because the x squared, the square root is x to the first.
Is it 2 different?
So there's not.
Oh, y'all making me. Miss Michaela?
The one only.
A semicircle. It's the top half of a circle. Because if I square both sides and then add x squared to both sides, I just have x squared plus y squared equals 1, better known as the unit circle. That's just the unit circle. And the square root's the top half of the unit circle. So if I graph that, radius is 1. Here's what that looks like. Say like I hit this big dot at the top. And how would I find that area using geometry, because I can't use calculus to do that at this point in my life? Area equals a half, since it's a semicircle, pi r squared, and what is r? 1. And so in other words, that's just pi over 2. All right. If every function was some geometric shape that we had a formula for, then we wouldn't need calculus at all. But it's not. So we've got to figure out a calculus way to get this same. Okay, piece of chewing gum foil just appeared right here out of nowhere. That is truly weird. I did not have it up my sleeve. I have no idea where that just came from. It was Davis. Okay, we have to figure out a way to get that same answer with calculus rather than geometry so that we can apply that to other non-geometric formulas. There's no such thing as a non-geometric, but not a regular something we know. Evaluate that using a trigonometric substitution x equals sine. When have we ever wanted to change algebra to trig? Never. But let's see if it works. If it works, then maybe this is something that will be helpful to us. Don't forget when you're evaluating a definite integral, if you do formal substitution, you have to change the bounds of integration as well, because x won't be the same thing as theta. If we're going to let x be sine theta, and I don't know why, somebody just told me to, I'm going to see if it works. If x equals sine theta, then what is dx? Cosine theta d theta. And let's change the bounds of integration. If x is negative 1, what is theta? Which is negative pi over 2. Last night I started by calling it 3/2 pi, but then I remembered, no, I need to call it negative pi over 2 because inverse sine always gives you an angle between negative pi over 2 and positive pi over 2. So when x is negative 1, theta is negative pi over 2, and when x equals positive 1, theta is positive pi over 2. All right, so let's do some substitution here. We're going to put negative pi over 2 to positive pi over 2 in for the bounds of integration. And then we're going to put sine x, or sine theta in the place of x. Don't know why. And what are we going to put in place of dx? Yeah. Cosine theta d theta. All right. How has changing algebra to trig ever made anything better? And 1 minus sine squared is cosine squared. And then the square root of that's just cosine. And then cosine times cosine is cosine squared. This is cosine. That's cosine. Negative pi over 2. I'm sorry, what? I'm just, happy for any little step I get. I'll worry about that in a minute. But the minute's here. I do have to worry about it. I didn't get to delay that worry for very long. You're right. If I look at u as being cosine theta, and that's u squared, then du's not right beside it. One of the formulas. We had 2 little formulas in the last section. That's about as close as I get. Like, thank goodness that's given to me on the test. I'll just put an asterisk here and remind us that cosine square theta is 1 plus cosine 2 theta over 1. Because I have that written down, otherwise I forget it. I said 1, but I wrote the right thing.
Okay.
Over 2.
I was like, if it's over 1, then it's my point.
Yeah, what's the point? Okay. And we learned yesterday that it'll be easier to integrate that if I just go ahead and bring the 1/2 out in front of the integral. Make sure you realize that's taking that out of both terms. Integral from negative pi over 2 to pi over 2. And factoring out a 1/2. Oh, yes, we zoom just a tiny bit, because I want you to be, that's too much. I want you to be able to see when I factor out the 1/2, what does that leave me from the first term here? Just 1. And I factor 1/2 out of the second term, and it leaves me cosine 2 theta. 2 theta. Ms. McKay, do you see what we did there? Okay. And then I'm ready to anti-differentiate the antiderivative of 1 with respect to theta is theta. And the antiderivative of cosine 2 theta. All right. Maybe I should have broken it into 2 integrals. I don't know if you can see without it or not. But to integrate the cosine 2 theta, I would have to have a 2 d theta beside it. And I don't have. So if I put a 2 there, I'd have to have another 1/2 in front of the sine 2 theta. I'm going to double check that because I'm OCD and double check everything. The derivative of theta is 1. The derivative of 1/2 sine 2 theta is cosine 2 theta times 2. And that 2 times that 1/2 gives me that coefficient of 1 right there. So far, so good. All right. Now I need to evaluate it for pi over 2. What's sine of 2 times pi over 2? Pi over 2. And yeah, that's 0. If I put in a positive pi over 2. What about if I put in a negative pi over 2? It's also 0. So when I put in a pi over 2, I have pi over 2 plus 0. And then subtract what I get when I put in negative pi over 2. And then clean that up. It's almost like geometry and calculus agree on something. All right. The nice thing about tonight's homework is you're going to be told what to use for the substitution. We were told here, for reasons we didn't understand, let x be sine theta. And we said, okay, fine, and we went with it. Tomorrow, we're going to have to go, what substitution would work? But we're going to, we don't pre-worry. We'll worry about that tomorrow. Today, we're just going to, whatever it tells us to substitute, we're going to do it, and we're going to practice cleaning it up. And then tomorrow, we'll figure out how to figure out what substitution to use if they don't tell us. All right. So what about these three? 4, 18, and 14. You're going to tell us what to use. And I'm just thankful for anything I can think to be thankful of.
I'm thankful I don't have to come up with what to use yet.
Yes! Just be thankful you'll live to see another day. Where the heck is my blank pieces of, are my blank pieces? pieces of paper? Oh, I know they are.
It's all part of the
All part of the thing.
She planned the homework around the work schedule.
Okay. So, number 4. Page 547. The problem is, so I could just say square root as I wrote the integral. The integral of 4 over x squared times 16 minus x squared. It's yay, today's indefinite integral. Tomorrow we have a couple of definite integrals. Oh, and I need a d, and I need a dx. What are y'all saying? It looks like what? It does look like arcsecant, but then there's an extra x, because if this were a squared minus u squared, then u would be what? No, u would just be x. A would be 4 and u would be x. And so if we just had an x there, this would be arcsecant. But it's not. Okay. Thankfully, I don't have to think of what to use. They tell me to use x equals sine theta. No. They tell me x equals 4 sine theta. Okay, don't know why. I'm just practicing doing it. Okay, that's all they've given me. So what's dx? Or cosine theta d theta. All right. Our strategy on these is going to be how to write that radical in terms of the x that we're given. So over here to the side, let's work on this radical a minute. 16, square root of 16 minus x squared. See if we can figure out what that is in terms of theta. And then we'll resubstitute if we do. All right, I'm going to put 4 sine theta in the place of x. And I have that. Now I could do all of this in the body of the work, but I'm really just trying to figure out what that radical portion is. How is that helpful? What can you do? Not really, because it's not a binomial here, but just square the 4 sine square. 16 minus 16 sine square theta.
little factor of 16, so you can get a 1 minus sine squared.
Ooh, I could take this. I'll put in a middle step. I doubt that you need it, but I'm going to put it there anyway. 16 times 1 minus sine square theta. Are you going to do it?
This has never happened before.
Yes, you are.
Excited.
Square root of 16 is 4, and 1 minus sine square is cosine square, and the square root of cosine square is just cosine theta.
It's really upset
Why?
that works that way.
And it's almost so satisfying. Okay, we have our x that was given to us. We have our dx. We have figured out a trigonometric equivalent of our radical portion based on the x that we were given. So let's substitute and see what happens. 4 over x squared would be 16 sine square theta And in place of the square root of 16 minus x squared, we can put 4 cosine theta. And don't forget dx is not just d theta. What is dx? Yes. 4 cosine theta d theta. Oh, tomorrow we're going to know that.
I don't know about it.
Oh, yes we are. You call your friend and say, I love trigonometric. Are you? She'll probably laugh at you. Okay, so we have 16s that cancel. We have cosines that cancel. We have a 1/4 left in the denominator. Let's just bring it out front. And so all that's left of the integrand is what? Holy cow.
That's crazy.
What function has as its derivative cosecant squared? At first I would just think, yes. First I'd think, well, the derivative of cotangent is negative cosecant. So if I want a -1 with that d theta, then I'm going to have to multiply by -1 outside the radical. That's -1/4 cotangent theta. I started to say d theta, but no d theta. That's it. So far, plus c.
And then you're supposed to, like, plug x back into things.
Back substitution, because if we're given a function in terms of x, we don't want to give the answer in terms of theta.
How do you make cotangent 4 sine?
Yeah, how do you make it? Let me tell you the easiest way for me to do it, and this will also help us tomorrow when we're trying to figure out what substitution to use. If you tell me to use the substitution x equals 4 sine theta, then I'm going to say sine theta is x over 4. Just divide both sides by 4. And then draw a triangle and label it in such a way that theta is, sine theta is x over 4. Yes, triangles. They're almost as good as semicircles, but not quite, all those pointy edges. So opposite is x. What's the 4? Guess what? Guess what the adjacent side is? Square root of 16 minus x squared.
Oh my God.
Oh.
But how did they know in the first place?
We were not worried about that today. It's not going to be bad. It's not.
Makes sense. Perfect sense within no sense at all.
No, how did somebody figure this out without a teacher is what I'm trying to understand. My husband and I always argue over whether math is invented or discovered. The symbolism, the symbols are invented. Somebody had to come up with that symbol. But everything else was discovered. Okay, we're getting all philosophical here, and this is, did I ever tell you about the student who wrote on my student evaluations, this is a math class, I shouldn't have to learn literature? Did I reference a book in class? Heaven forbid.
It was David's.
This is a math class, I shouldn't have to learn literature, I shouldn't have to read. Okay, so what's cotangent theta? Adjacent over opposite. just did something we never could have done before. Because somebody gave us a little bitty nudge at the beginning. And it's really not going to be that hard tomorrow to figure out how to figure out which trig substitution to use. Yes. Okay. So far, so good, right? Let's do another. I'm happy to see y'all smiling instead of crying. That's so good. Number 8.
Obviously, you should know x is 2,400 sine cosine for theta.
And it's not a variable. It's just a constant we don't know.
That's not fair.
We're given the nudge. We don't have to figure it out today and tomorrow. When we do have to figure it out, it'll be fine. So what's d theta? Or what's dx? I'm sorry, dx.
There's always like a radical that has like,
Well, that's how you know when we're using trigonometric substitution. It's not arcsecant or arcsine, both of which have radicals. And so you go, oh, then let's try trigonometric substitution. Mm-hmm.
I hate theta so much.
and there's going to be a difference of two squares.
The answer is no. Okay, let's do one other thing. No, that's not. Let's try to figure out the radical part. Start with the x squared minus 25. Put 5 secant theta in place of x. Things gonna happen every time. You put in as many steps as you need to, but you practice a little bit and you start skipping steps. You end up with one more step. So what's the square root of 25 secant squared minus 1? 25 times, in parentheses, secant squared minus 1. 5 tangent theta. No, square root of tangent squared is just tangent. All right. You know how y'all have seen me do this? I usually fold my paper in half and work problems down one side from back. These take up the whole width of my paper, and I usually have 4 columns going. This is just my style. I'll work on the original problem. I have to find x and that's supposed to be dx. Darn it! Did y'all write what I wrote or? Okay, and then you had a d theta on the end. Okay, you know me so well. All right, that's what I meant. Dx is 5 secant theta tangent theta d theta. And then I have a column for figuring out the radical expression, and if I need it, I'll have a little bit of space to draw my triangle over here. That's when you use trigonometric substitution.
That's good to know.
Yes, it is. If it's not arcsine or arcsecant, our other 2 big things with radicals in them, then maybe it's this. All right. Take another deep breath. More oxygen to the brain. What can we put in place of square root of x squared minus 25? 5 tangent theta. And what can we put in place of x? And what do we put in place of dx? 5 secant theta tangent theta d theta. Do we know a function whose derivative is tangent squared? I'm hoping I'm going to have to use trigonometric substitution twice in one problem.
Is it tangent also
Yes, but if you're thinking of it that's just tangent, not tangent squared. If I was taking the derivative of tangent squared, I'd have to have 2 tangent secant squared. Remember? I'd have to have the derivative of the ugly.
Oh, 1 minus, I mean, secant squared minus 1.
1 plus tangent squared, secant squared minus 1. Yes. 5 times secant squared theta minus 1 d theta. And what's the function whose derivative, oops, I don't need the integral anymore. What's the function whose derivative is secant squared? Tangent theta minus what? Theta.
Theta?
Those are variables, theta. Thank goodness this is not a definite integral, so just plus c. But then that's not my answer because my original problem was in terms of x. I don't want to give this answer in terms of theta. You know, that's a good point. With a definite integral, you don't have to back substitute, but you just have to remember on the front end to change the bounds of integration. I wish my 21-year-old crying in my Calculus 2 class could have heard me say that sentence. That mean teacher. Okay. We have x equals 5 secant theta, so secant theta is x over 5. We want to label our triangle in such a way that secant theta is x over 5. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so secant will be hypotenuse over adjacent. X is 5, hypotenuse is x, adjacent is 5. What does that make the opposite sides? How about that? You're not going to be able to sleep tonight. Feeling excited about tomorrow. Okay, so 5 times, in the place of tangent theta, I should put what? Opposite over adjacent. And in place of theta, I should put what?
It sure is.
Wait. We solve what for theta? I have writing all over the place. Here, or even here. How would I do that? about that?
It's not a variable, it's a constant we don't know, so it just doesn't exist now.
It just makes a different constant.
Is that the answer?
You could distribute the 5. Do so carefully because the devil will get you if you cancel this 5 with that 5. Ta-da! On its own sick way. Mr. Sam, your tech teacher may have known calculus 2 better, but could she have made it more fun? No. Okay, what's my other one? And then there's something else I want to show you. 16? 14. Oh, that's my sheet from last year. 14. This one's a little bit longer. We'll get there. But I'm going to use the document paper just in case.
Columns.
Mm-hmm. No trick, no tool that I have in my toolbox would handle that. My gut would be to say, let u be 4x squared, but then du would have to be what? I'm just saying, if this problem's on a text, my first gut would be u is 4 plus x squared, du is 2x. So this is x squared, and I could write that as 2x times another x, and then what could I do with that other x? Do we have a way of dealing with extraneous x's? If u is 4 minus x squared, then x would be the square root of u minus 4, and we could do formal substitution. We have done that to deal with extra x's before, and we could do it here, but the trigonometric substitution is going to be easier. Tell me what you're thinking.
Is x 2 tangent theta?
Excuse me?
Does it tell you that x is supposed to be 2?
Yes! You can do tonight's homework. I mean, tomorrow night's homework already.
Sure won't.
Yes. Now, see, Miss Sam, honestly, I know how you got that because I've done this homework before. How did you just figure that out with no hint being given?
With 20% guessing, 80% patterns.
You are better at seeing patterns than I am. Somebody has to write a pattern on a sign and hold it up and let me study it a minute before I see a pattern. It does. I know what you're talking about. If that was just 1 over x squared plus 4, that would be arctangent. Okay. Yay, if you can figure that out. Why? The rest of us are just going, okay, we'll use it. If x is 2 tangent theta, then what is dx? Right. And how, oh, a minute ago I said they're always going to have radicals. This one doesn't have a radical. Okay, so, because the arctangent doesn't have a radical? Okay, so let's just try to figure out what 4 plus x squared is then. 4 plus x squared would be 4 plus 2 tangent squared, no, tangent 4 plus 2 tangent theta squared. Or 4 plus 4 tangent squared theta. Or what? I don't know why, but fine. All right, let's go over here and rewrite our integral in terms of betas instead of x's. Whoever thought we wanted to do that? In place of every x, I'm going to put a 2 tangent theta. Look up and see if we agree. I saw that slow blink. I was like, oh, I can't believe this is real. Me too. Me too. So it's ugly, but everybody on the same page? Yes.
Just solve for the 4 plus x squared, so we could put 4.
Oh, I forgot that. Okay, I'll do that in the next step. Yeah, that was kind of the whole point. Okay, I forgot that we have just, in the place of 4 plus x squared, we could have just put 4 secant squared. So I'll do that in the next step. This 2 squared is 4. That 4 times 2 is 8. Tangent squared theta. I might as well go ahead and say times 2. I'm going to give you one more chance before I throw you in the fire like you see in Bill. There we go. I scared it and it straightened up. 16. Tangent squared theta, secant squared theta. And in place of everything I have inside the big parentheses there, that's just 4 secant squared theta. I still have that big square outside. So far, so good. Right, and then it's going to steps if you need to not make a mistake. And there will be more stuff in your head than I will, and it's fine. Somewhere along the way, I lost my integral sign completely. Mm-hmm. Tangent squared over secant squared. So far, so good. Okay. Maybe we could clean that up if you wrote it in terms of sine and cosine. Yeah. So tangent squared, sine squared over cosine squared. And dividing by secant squared is the same as multiplying by 4. So what are we actually integrating? Look, all of this stuff is sine square theta. Well, that's not exactly true, because dx is not the same thing as d theta. But I'm going to give it to you. If you have that memorized before I do, I'm so impressed. It's note given on test. Sine square theta is 1 minus cosine 2 theta over 2. And that's just on yesterday's notes, Michaela, and it says, I'll give it to you on the test. So, I can bring the 1/2 out front, and I'll just be integrating 1 minus cosine 2 theta d theta. So far, so good? All right. What is the antiderivative of 1 in terms of theta? Theta. What is the antiderivative of negative cosine 2 theta? To integrate that, I'd have to have what besides the d theta? 2. And so I'd have to have another half outside the integral. And then I'm just going to double check my SIG in here and say, if I take the derivative of 2 sine 2, negative sine 2 theta, do I get negative cosine 2 theta? Yes. That's the concept. I think, and this is just me, but I kind of think I'd like to factor out a 1/2 before I do the substitution. Just so I have my fraction outside brackets, I don't have to worry about it. If I factor out another 1/2, then what's left inside those brackets? Let's see. So far, so good? All right. It's time to do some changing thetas back to x's. So I'm going to take my x equals 2 tangent theta, going up to that other column, empty column on my paper, and say if x equals 2 tangent theta, then tangent theta equals x over 2. And I can draw a picture of that. Some angle theta whose tangent is x over 2. That means opposite is x, adjacent is 2, and hypotenuse is what? So the trig value that I need to extract from that triangle is what? To plug into what I have in my integration. I need sine, so what is sine of, I got another problem here. Another issue. I want to call it problem. I have another issue here in that I have drawn a triangle with some angle theta, but I'm asked to extract from it not the sine of theta, but the sine of 2 theta. Either I'm going to have to draw another triangle with an angle being labeled 2 theta, which would just really mess with my head, or somehow I'm going to have to get that to not be a 2 theta. Oh, yes. The only double angle formula I have memorized. Mm-hmm. And that's just over here to remind me what I just did. Sine 2 theta is 2 sine theta cosine theta. And I can extract those off my triangle. So 1/4 of 2 times, what do I put in theta, in place of theta? I'm not putting in something in place of a trigonometric function of
Oh,
theta.
like the first theta?
Yeah, this theta. Yes. If x equals, there's another asterisk to show me what I'm substituting. If x equals 2 tangent theta, then x over 2 equals tangent theta, and guess what theta equals? Arc tangent x over 2. And what am I going to put in place of sine theta? And what am I going to put in place of cosine theta? Which is constant times t. Does. Actually, since this second numerator is going to be 4, I'm going to redistribute that 1/4. And there's a variety of things that would be okay for the answer. But I think the simplest would be 1/2 arc secant x over 2. I said secant and I wrote tangent. What I wrote was correct in that case. 1/2 arc tangent x over 2. And then -4 times 1/4 is just -1. And so the numerator is just what? And the denominator? I'm going to take this to pre-calculus today and scare them because they're not believing how good they have to be at algebra, trig, and calculus.
I know, it was just the first time it's happened in over a year.
Yeah, I cannot pass those babies if they still say x plus 4 in parentheses squared is x squared plus 16.
Where are they still doing that?
Of course they are. Of course they are.
It's October.
I know.
It is October.
And I gave them, 6 people failed the first test, and I gave them a chance to retake it if they redid the problems that they needed to do to get better. Only 2 of them did.
What?
No offense to your students, but they're not failing doesn't make them stupid, but not retaking it doesn't.
That is exactly right. Not availing yourself of the opportunities of it.
I wish we got retakes in here. You know how much? I wish.
Hey, you're getting 100 for attendance.
No, I'm still though. I need to test in the iron A for
Okay, let me tell you the one thing that we did not get to do, and I'm going to ask you to look at it and try it. And what we did not get to do was these last two examples, but they're using those formulas.
Okay.
And so y'all are great at using formulas. The cleaning up is a little bit ugly, but try the homework that I have listed for day 1 there, 3 through 17, and the last 2 or 3. Try to use those formulas, and we'll do one if we need to tomorrow. And also tomorrow we're going to figure out how to do trig substitution if they don't tell us what the substitution is, which is saying REMs. Huh.
I
I
think
don't
if you
know why,
figure out the
it's just-
coefficient, it's the trick for them kind of like
How do I know?
random guess.
I had a 30% chance.
Spin the
It's
wheel.
either secant or tangent or sine, probably.
There's like a few trick functions. You're not going to get
33% chance. If you're satisfied with a 33% chance,